Hi everyone, Greg here. So today I'm going to demonstrate how you can load a web page in C. Anytime you want to do something with networking, you need to make sure that you know and understand the protocol layer cake really well. So the way you access the internet, and in particular the web, is you use a couple of protocols stacked on top of each other. So you will typically access the internet either through the Ethernet or Wi-Fi. This is implemented in the hardware itself, and as a programmer you typically don't need to worry about this. Then there are two layers that the kernel will give you for free. One is the IP protocol, which stands for the Internet Protocol. So every computer connected to the internet has an IP address. The same way every phone in a phone network has a phone number. So every computer on the internet has an IP address. This simply allows for the location of a particular computer or the location of a website. Okay, then you have TCP, which stands for Transfer Control Protocol. Basically, this does the accounting, right? So when you contact, let's say, example.com and you get that web page back, that web page won't necessarily come to you in one piece. It will be chopped up in several packets and it will be sent to you in pieces. TCP will make sure that those packets are numbered and it will account for every single packet. If for whatever reason a packet doesn't arrive, it will ensure that those packets are being sent again. And it's basically ensuring that the entirety of the website comes to you. So that's what TCP does. And then we have HTTP. We're just going to look at HTTP today. The S stands for secure, and that deals with encryption, which is a whole other kettle of fish I'm not going to touch today. But HTTP, Hypertext Transfer Protocol, this is basically what you use for websites, and this is your responsibility when you write an application. So this the kernel does not actually deal with. So another thing to note is DNS, which stands for Domain Name Service. So when you have a website like example.com, well, example.com is not an IP address, which is what you need to contact the website. So DNS will convert that domain name to an IP. And so DNS is used because human beings typically find it very difficult to remember numbers, and something like example.com is much easier to remember. Now, fortunately, you do have a series of tools at your disposal to do DNS very easily. For instance, in the terminal, I can just type in example.com and then it will tell me what the IP address is of that website. So very trivial to do, and there are similar tools available when you code in C, and we're going to look at that just in a second. So you're going to see me do everything in Linux. At the end, I'm going to show you some platform independent code, so it will run on the Windows as well. It's going to be on the GitLab, and I'm going to also explain how to run your code on the Windows. Alright, so now let us have a look at the code. The way I want this to work is I want to be able to say get and then the domain name, and then it will just print out that web page. So the way we're going to do this is we have the main function here. This deals with getting the arguments from the command line. The first argument is always the name of the command itself. So if we have fewer than 2 arguments, that means that no domain name was provided. The first bit we do is DNS. So this function here, get host by name, we pass on the domain name, and this will figure out for us the IP address that we need. So this returns this particular structure. There are potentially more than one IP address that match that domain name, so they're going to be in this list here, part of that structure. We're just interested in the first IP. We use this function to convert the IP address. That IP address will be in binary form, and we convert it to a string. The familiar IP addresses where we have the numbers separated by the dots. So this function rather deals with the conversion. It also deals with byte orders, the The bytes might be in a different order depending on what we're dealing with, network byte order or the byte order on the host machine. And so this function just will deal with all of those intricacies. So here, socket, here is where I actually begin the connection to connect to example.com. Here we have a bit of archaic terminology, right? So AF stands for address family. So this type of API is very old. Now, in the 1970s to 90s, you had many different network technologies that were competing with each other, and the internet was just one of them, right? Another example was DECnet. DECnet from the DEC Corporation, DEC, which stands for Digital Equipment Corporation. They had their own networking protocols. So eventually TCP IP, the combination of those two, won out and became the king of the web. The king of networking, essentially. But because those APIs are so old, INET stands for internet, so you actually have to tell the kernel that you want to use the internet as your networking technology, as opposed to some other one that nowadays would be completely obsolete. SockStream is just a different way of saying TCP. I suspect this is also a terminology that may have made sense at some point in time and just kind of seems weird today. So FD, file descriptor. So in Unix/Linux, everything is a file. So we have the socket file descriptor. If it returns -1, we've had an error, right? Otherwise, we'll open the socket. Okay, so here connect. Here is where I tell the kernel where I actually want to connect to. So the IP address of example.com. And I do that by passing on the address to that structure, server address. Server address, I declare that over here, and I'm filling it in here. I'm telling the kernel it will again be the internet that we're using here. And the port number. The port number is something that matters for TCP. When we're dealing with HTTP protocol, we always use port 80. The port number. This function again deals with network byte order. So we just make sure it's in the right form to put it into that function. And then the IP also has to be placed in that struct in the correct form. And so this function here ensures that it gets placed into that structure in the correct way. And we pass on the address of that structure and the specific field within the structure here. So when we have all this done, we just tell the kernel to connect. Okay, so all of this stuff here is basically boilerplate stuff. It is just a way of getting the correct IP, starting the connection. I don't think too much about it. I write it once, I make sure it works, I put it into my personal library, and then I just keep using it. And, you know, I don't always think that through. It's probably a good thing to study it carefully once, make sure everything is the way you want it, and then just forget about it. So what I've said is that if we want to use HTTP at the application level, we are responsible for the implementation of that. So here we have the header, right, which is just a character string here, header. And this part here is the actual HTTP header. This is what is going to tell the web server, hey, we're here at example.com. This part here will be replaced with example.com. And we say, we want example.com. We hope we're at the right place here. We just want to see the / is basically the default page. So that's going to be the index.html. So we want to get that. We're using this protocol. Please send us back that web page. Right? That's basically what it is. Then we're actually sending it. We're using again, the socket file descriptor here. We are sending the header. We're telling the kernel how long the header is. And what it returns is the number of bytes that were actually sent, right? Which should be the length of the header here. And then we'll just wait, and where's the function here? Receive. Receive is where we actually get the web page we're looking for, right? Now, the thing with receive is that we don't necessarily get the website. We don't receive the website necessarily all in one big chunk. It will be sent into packets, like I've explained earlier with TCP. And we want the data, the actual web page, to be placed inside the buffer that we have here. So we have allocated some memory. The size of the buffer, this, we just initialize it to 0, and then we let the data of the website get in there. When we get the data, it will be sent to us in packets. We don't necessarily get it in one go, and so therefore we have to run this function in a loop. So we print whatever is in the buffer, we clear the buffer, and then we're ready for the next couple of packets, and we just run this in a loop. Now, this loop, there's a couple of issues with this loop, and I will talk about that in a minute, but this will do for now. This is the first version of this code. It's more or less the simplest version of the code, and we're going to talk in a minute about what's wrong with it, and we're going to improve this, and we're going to make it a lot better. But first, let's demonstrate that this actually works. So I have the code here. Yeah, that should do it. So there we are. And then now, let me first show you that it's there. Okay, so example.com, and let's see. And then now we get our web page. So this worked. This worked. We got the web page. And this is a bit of debugging information that we have here, where it says socket opened. So we got this over here, and we got a successful connection. This is the header we sent. Again, we didn't need to print this, but that's fine. The number of bytes that we sent, right? So all of this adds up. And this is where the response from the web server actually begins. This is what we got back, whatever is below this point, right? We are seeing that this is actually the HTML document, right? The actual HTML document, and this is the HTTP header that precedes it. Okay, so this is our example.com. We got everything. We know it's everything because we have the end tag here. But what we notice is we don't get our prompt back. Like, what's going on here? What's going on here is that it is stuck in this loop. Okay, it's still looking to receive stuff. Right? Now, why does that happen? Well, we made a connection, right? That happened at the kernel level. The kernel doesn't deal with HTTP. The kernel doesn't know that once you get this tag, that's the end of the connection. In fact, that is true by convention, but it's not necessarily true. You could, in theory, have data that comes in after this tag. So the kernel doesn't know that this is the end. So what happens is that this function will check, is there something in the buffer in the kernel, anything, any response from the web server? If there is, it will copy that into our own buffer, and then it will return the number of bytes it just copied into our buffer. If there is nothing in that buffer, well, it will just wait, and it will just wait until something comes in. This is known as blocking, right? So the function just hangs there. It just keeps running until something comes into the buffer and it is ready to return. So now maybe you might think, oh well, maybe if we do a non-blocking approach, we can change the settings of this function. What if we do non-blocking? Well, that's not going to help us, because if we do non-blocking, the first time you run the function, the response from the web server probably hasn't arrived yet. So it will see there's nothing in the buffer, and then the function will terminate, the program will end, and we won't actually get our web page. So that's also not a solution. So how do we deal with this? Well, here in the HTTP header, we are being informed that the content length is 1256. That means once we are past the HTTP header, we get 1256 bytes of data, and then it ends. So it's up to us to realize, okay, we got all the data we need. Now we can terminate the execution of this program. So why did my prompt come here? Did I? Oh, that was just a timeout, right? So eventually this will time out. I've been talking for too long. That's what's going on. Eventually this will time out and return, right? Otherwise you have to use Control-C to terminate the program, right? So let's see if we can create a better version of this that will detect that we got all our data and then terminate by itself. Okay, so now I have written version 2 of my code. So let me just show you. There are 2.c files there now. Okay, now the changes I made is, first of all, I want to be able to do this, right? So have a web page rather than just a domain name. I want to have the option to put the protocol there if I want to, and of course have it both ways. And then obviously I want the program to end gracefully. So let's just test that here now. And then we see that indeed now I get my prompt back straight away. Okay. And we did process the header. That's the end of the processing. And it went through the header and it figured out the number of bytes it had to read in. All right, so let's have a look at what that looks like in the code. So the first bit is the same. Then we remove the HTTP, because when we're going to do the DNS, we have to make sure that that's removed. So, oh yes, I did include quite a few functions from my personal library. So the prototypes are up there and they're all included in the code. And if you want to, you'll be able to look at that in the GitLab. But basically, it just says, okay, if the buffer begins with the protocol, then we just skip ahead by 7 characters. So we basically jump over that. Here is when we separate the domain page, the domain and the web page. So whatever comes after that /, and so we just copy into those buffers, right? Then we resolve the host. So this is basically the DNS bit you saw earlier. I put that in a separate function, so that's the same here. Get host by name, right? And that bit of awkwardness over here. And so this will return the IP address as a string, the familiar notation of numbers and dots. Right, and then here we actually receive the web page. So let's have a look at what receives looks like. All the boilerplate is the same. So we have socket here. We have this struct server address that is being initialized and filled in. We connect. So all of that is pretty much the same. Now here we get to the point where we determine the HTTP header. This is slightly different in the first version, this was just a /, but now that we have the possibility of specifying a page, a specific web page, we have an extra string here that is being placed into this header. So then we send the header. All that is pretty much the same. We use this receive function, and we make sure that receives copies the website that we are receiving into our buffer, right? This time, previously we had just a loop there. Now we have process header, right? So we'll process the header. Then the mem move is because once we have processed the header, we want to pass on this buffer to load body to get the actual web page, but we're going to move the header forward by whatever number of bytes the header consists of. So new buffer actually tells us where the header ends and the web page begins, and so we move the buffer by that amount. And then we close the socket, which we weren't doing in the previous version because, of course, the receive function, it just hung on us. But this time we're going to be able to properly wrap things up and finish things. Right? That's just a bit of debugging code so we can see everything clearly. Once we're done outputting the web page, we just have those couple of asterisks there. So process header is like a big change in this second version. So what we are looking at is we are checking that the header begins with this 200 code. 200 means that everything is okay. So there are different codes. 404 is a famous one when the page is not found. There's loads of those different codes, but the only one we're really interested in is 200. That means everything went all right. We actually getting the web page we requested. And so if we get anything else, we just print unexpected header. Okay. So we're going through the header. Right? In a loop, we're looking at all of the fields. We're checking for every field. Does it begin with content length? Because that's what we are interested in. And at the end of the loop, we're looking for the caret return and the new line, because that is what we have at the end of every field. So basically, this function here will return the index where it finds the first instance of the caret return and the new line. So the index at the start of the caret return and the new line. So we bring the buffer forward by n, which is where that starts, and then +2 to skip over those two characters as well to get to the start of the next field. So we keep doing that and we keep checking, is this the field where we find content length? At the end of the header, we're going to see the caret return and the new line repeated. So when we get to the next, when we get to the last field, we're going to find the caret return and the new line. And then what we follow immediately after that is another caret return and a new line. So when we get to that point, we know, okay, this is the end of the header. Now, if this returns true, in other words, that's the field we were looking for, we go inside this if, we move the buffer forward by whatever length this is, and then we convert the string to an integer, and then we figure out what the actual length of the web page is. And then it returns buffer. And size is actually a variable in our function. It was passed on by reference, so this size will contain the size of the web page, and when we go back here, then this variable here will actually contain that value. So then when we do load body, we have the buffer, we have skipped over the header by that point, and we know how many bytes still to expect. So load body, if size is smaller or equal to 0, then something has gone wrong, so we just return. We keep track of how many bytes remain. So we look at the length of the buffer, and we subtract that too, and then we print this. So what we're basically dealing with here is whatever receive gave us and put into the buffer, we get past the header, and then we print whatever part of the web page already came along with the first receive, right? And then we do receive again, and then we print that again. We just clear the buffer, we account for how many bytes are remaining, and we keep doing that until receive is telling us that we're no longer getting any bytes. So the number of bytes is 0. That means we got to the end. Or once remaining is 0, then we got to the end. And of course, there really should be 0 both at the same time, but I think it doesn't hurt to have them both in this condition here. So where does load body end? Here, we just close the socket, receive, and that's basically the end of it here, right? If we had to do some extra stuff here, doing a malloc, then this is where we free this, and then we finish the function, or we finish the application. Okay, so now you might think this is pretty good, we've done it, we're there. Unfortunately not. Okay, let me try another example. I will try another website, and now what do we see? We see that basically it hasn't worked. We didn't get that web page. Now why is that? What's going on? Well, I'm gonna use the first application that I made, and here you're gonna be able to see, of course, now it hangs again, right? We get a 0 here, we get a 1, we get some crap over here. What is all this? And then when we go up and when we look at the header, we see that there's no content length like we would expect. Okay, this is the start of the header. It says 200 OK. And then we see transfer encoding. It says chunked, but there's no content length. What is going on here is that this website has decided to give us the website in a different way. Once that we are past the header, it will give us a hexadecimal number. This is the number of bytes that follows, and then another hexadecimal number with the number of bytes that follows, and then another hexadecimal number, and it keeps doing that. It keeps doing that until we get to the end of the web page and we get 0. So we don't have a content length here. Instead, we get the website in chunks, and we didn't write an application that can deal with that. So what I'm going to do now is I'm going to write a third and final version of this code that can deal with chunked with a chunked transfer of the website as well. Okay, so now I have the final version of this application. Let me just confirm that it works. There we are. And now if I do this and I try to get the website that didn't work earlier, then we're seeing that indeed now it is getting us the website. Okay. And here it is telling us that it was chunked. Here we've finished processing the header, right? And obviously the example.com still works as well, right? Okay. So the changes that I have made, there are quite a few changes here. Now I made this platform independent. That is to say, it can run on Windows. I did actually run this code on Windows in a virtual machine, so on my Linux laptop, just to make really sure that it really does work. So header files for Windows and header files for Linux. We have with Windows a little bit more boilerplate. So you have to do this extra step here to initialize the library that will allow you to use the sockets. So there's a little bit of that. Resolving the host, this is the same. All of the business of separating the domain and the web page, all of this is the same. So when we go to receive, here the IP address, putting the IP address into that special server address struct. There's a little bit of a different way of doing it. Again, don't worry about it. The code works, and you know, you can examine the detail if you want, but it doesn't really matter. So most of the things here are the same. Obviously, process header is where we're gonna see quite a few changes. So where is it? So here's the function process header. Beginning is the same. We're just looking for this magic number 200. Make sure that we get the page effectively without any errors. Now we look for content length as one of the things we could encounter, but we're now also prepared for seeing transfer encoding. If we see that, we just assume that the that we're gonna get it in a chunked fashion. And so we have, if we get content length, this variable size will contain the actual length. If it is chunked, then the size will be -1. The rest is the same. It just goes through the header. It returns the buffer. So now if we go to process header again, here load body, and we pass on size. Okay, and then yeah, let's just go to that first. So load body. Now here quite a bit of stuff has been added. Okay, so when size is bigger than 0, then we have a fixed length, and then we're doing pretty much what we were doing before. If size is -1, then this is when we have this chunked situation. We take the hexadecimal number, which is a string, we convert it into an integer, and then we're going through a loop, and we basically get this entire web page in. We have this function put into buffer, and this function will then I think it calls another function, and then it calls the function receive, because again we might get the website into different packets, and we so we have to make sure that we keep calling that function to get the entire page. So we're getting size. Immediately after that hexadecimal number, we get a carriage return and a new line, so we have to jump over this, and then whatever follows that hexadecimal number, and those 2 characters will be the actual content of the website. So we have this function put into buffer that deals with taking the whatever follows and put that into our buffer and output it to stt out. This will also call the function receive and just get the next chunk. And so we have this thing in a loop. Eventually, that hexadecimal number will be 0. So at the end here, we convert that hexadecimal number. Eventually, it will be 0, and then the while loop stops, and that is when we have all of the content of the website. You now have an application that can load the web page, a web page, as long as it's not encrypted, can load a web page in C, and you can include that in your own code if you want to. You can use it for web scraping or whatever you want to do. So here you can see how I did compile under Windows. I did use MinGW, which is the Windows port of GCC. The first step is to export the path. This is to make sure that Windows can find the compiler and all the dependencies. Then a normal command. Just note how you actually have to explicitly add the library winsock in order to make sure that it works. You see a couple of warnings. You can just ignore them. And then as you notice, I ran the code and it's running just fine. I hope you had fun. I hope you learned something. If you did, give me a like, subscribe, and I see you in the next video. Thank you.